Like we move to our first invited speaker for the day, which is Andrea de los Ángeles Blengini.
Blengini, yeah.
Blengini, I'm sorry, from the National University of Patagonia, San Juan Bosco. And she will be talking about the Chinese writing system and the periodic table of symbols.
Okay, hello everyone. I'm very glad to be here, and Adam's talk was very interesting for me because I'm interested in languages as well as chemistry. So today I will try to gather and share with you some thoughts about the Chinese writing system and the periodic table symbols in a way to captivate students' attention when we are teaching the elements, the symbols of the elements in Spanish in our case, in English in other countries. For that, I prepare a list of stepping stones that we are going to go over. We are going to start, as I like to start my classes with my high school students, playing a little game. Due to the lack of time during the presentations, I will just challenge you, and you're going to play by yourself, and then we're going to reveal the answers, okay? Then we're going to compare the writing systems in Chinese, and the Western way of naming the elements. We are also going to recall or talk about a little on how chemistry is a language and some characteristics that chemistry has as a language. We are going to also talk about some processes in transferring information from short memory or working memory to the long-term memory. And to finish the presentation, I will try to give you my reasons, what I think, why teaching chemical elements in Chinese is useful as a pedagogic strategy when teaching high school students. I will give you some, okay, I need to use this one. I will give you a couple of seconds for you to check the symbols here. If anyone knows Chinese, it's gonna be easy. If not, it will be very fun for me. But what I will ask of you is that you try to find something that they have in common. Okay, they have some elements in common, and I would like you to take a look and answer to yourself if you were able to find the things that are common to several of the symbols.
Right now? Right now?
Yes, right now.
Okay.
Don't give me the answer. I'll just give the slide a couple of seconds. Let's say 15. So you can take a look.
Something to say about that if you want to.
Okay.
Well, I can see that in some of them, there is in the left part of the character, Chinese character, there is a two-member character, which means has the notion of metallic, right? That's the meaning in general, and in the first one, second, and last one. And some of them, there are this left character, which is means metallic character, right?
Yes. Can you identify, give me the numbers in the first row and in the second row?
No, at this moment, I don't know. I can't do that.
No, the name of the elements. In which characters did you identify?
Okay. Well, let's say, for example, in the bottom one to the left, and also in the first one, first one in the top, first one in the bottom line, and then I can see the last one on the first row, and then let me check. Probably this one, the third one, the bottom, but I'm not quite sure about that one.
Okay, thank you so much. Yes, you got those two right. Now I'm going to reveal, because I cheated a little bit because I like to have fun when I'm teaching. So here we have the pairs, okay? I intendedly chose 4 pairs of different symbols, different Chinese characters, and they share what in Chinese is called a radical or a root. The Chinese system is organized in small chunks of radicals that can help you build new characters. In this case, we have this radical that is 吃, which means gas. One of the meanings is gas. In this one, this radical is 是, and it means solid or rock. This one, as you said before, is tin, and it's the symbol for gold or metal. Here we have shui, and as tin, I forgot to add the complete one, but here we have 2 ways to represent shui, which means water or liquid in this case, okay? So you can see it here in xiu, which is a symbol for bromine, that you have the water or the liquid characteristic in this element. And here, this one is for kong, which is mercury, which is also liquid. It's also a metal, but in this case, they chose to use this as a main characteristics, as it is a liquid. So here, in this case, we have tin, which is hydrogen, and this one is liu, which is chlorine. This one is dian, which is for iodine, which is solid, and you have liu, which is for sulfur. This one is na, which is sodium, and this one is a very old one, which is tie, which is iron. So when we are learning or when we are teaching chemistry, we are asking our students to go from a very concrete way of thinking to a more abstract way of thinking. One way to help them go through it is to prepare small activities that will help them work with this transition. They can touch, they can identify elements, and little by little, they can connect the dots and start working in a more symbolic way. Why did I choose Chinese? First of all, because I'm a Chinese learner. My Chinese is not good at all at this point, but I'm trying to. And I find I have very important that teachers are motivated as well as students when teaching something. So for teachers, we tend to teach the same content over and over again throughout the years, and that becomes very boring for us. And also, yes, and also this diminish the quality that we use in our classes. If we are trying to use different aspects, like in this case, linguistics and also multicultural information, we are making chemistry not something that you teach using formula, but you are also using things from different sciences or different subjects that the kids also take in school. There are some things that we have to consider in order to understand why Chinese symbols are the way they are for the names, not the symbols, because the symbols, they use the same ones, okay? They use H for hydrogen, they use the same symbols all around the world, as we know, but in the names, we can get extra information that we don't get in the Western names, okay? We need to understand how Chinese characters or hanzi are conceived. We have pictograms that represent the concept, okay, or the object. In this case, Zhen, it's a person. And if you use a little bit of your imagination, you can see a walking person in the character, okay? In the case of ideograms, they represent abstract concepts. San gives the idea of 3. For the periodic table, they decided to go with the semantic phonetic compounds that use one of the radicals or roots that gives a property, it gives meaning to the character, and the other one is the one providing you with the phonetics for that character. In this case, the character is Li, which is lithium. And as we all know, lithium is a metal, okay? In the case of associative compounds, they use different characters to combine, and both of the characters help to build this the meaning. In this case, Zhen and Tu make Suo, 2 people sitting on the ground, and the character means to sit. Okay, that's the way a basic knowledge on Chinese for those who are not related or they are not familiar with Chinese. How did the Western knowledge of chemical elements got into China? Everything started after the Opium Wars with medicine people, and also with they use medicine and that knowledge also to share Christianity. So there were missionaries that were carrying all this knowledge of the Western medicine in contrast to the Chinese medicine. And that's how, at the late period, at the ending of the Qin dynasty, this knowledge and elements entered China. There were several attempts to produce the names. The first one was Benjamin Hobson in 1855, and he was the one assigning the new names for oxygen, hydrogen, nitrogen, and carbon in Chinese. And what he did was reflect the properties of the elements and translate it into a 2-character name. Later on, W.A.P. Martin and his colleagues translated or added to that list 30 elements. The ones that were kept from since 1855 were the ancient name for copper, gold, silver, iron, lead, mercury, and sulfur. They already existed in Chinese, in the Chinese language, so they kept it as a part of the names. Later on, John Fryer and Xu Shou, they decided, they were the first one to put in writing the rules that you have to follow in order to create a name. This is very important because when you change a language, you also change the understanding of the concepts. You change the grammar, you change the way that people think in a culture. So it's very important that when you make translations, you don't fall into the easiest way, which is the transliteration of the whole word. In Chinese, it's very hard to do so because they translate syllable by syllable. So at the end of it, you had a huge name that meant nothing but sound like the Western word. So that method was not going to be useful, especially if we think that they needed to add that in a table. So how long should a periodic table be if you are going to transliterate all the names. Rutherfordium, it will take probably 4 characters in Chinese to translate that name. So in this case, they decided that if an ancient name was good enough, if everyone knows that tin is gold, okay, we are going to keep that name. That's how they kept the ancient names. Then also they decided that, as I mentioned before, they were not going to transliterate every European term to Chinese. Also, they decided to keep Benjamin Hobson's translation, but they combined the 2 characters and make it to 1. In that process, sometimes in order to have an understandable character, because if you know Chinese, there are some characters that have so many strokes that it's very hard to understand them or to write them down. They decided to combine and sometimes change the original character and used an homophone. It's an homophone, so but they know where the name came from. Okay, that's a case of oxygen. And also they decided that there's going to be only 1 syllable, 1 character for each element. For some of them, they use the first syllable in English or in French or in German, because sometimes they translate it from German, and they added the radical indicated the property of the element. So if it's a gas, you are going to have the T character. If it's solid, you're going to have the Sh. If it's liquid, you're going to have Shui. And if it's a metal, you're going to have the Tin character added to the left. Okay. So if we contrast that way of naming and our way of naming, they have less categories than we do. Here, if someone takes the challenge and do the math, it's not going to add up to 118 elements, because some elements are part of more than one way of naming. We had the pre-chemical names that were accepted widely, and then we had different names referring to a different thing depending on the time that they were discovered. So that's why we have.
Sorry to interrupt. You have 10 more minutes.
Okay, thank you. Okay, so this is how if we want to know something else about the element and we studied the names in English or in Spanish, in our case, you also need to know some Latin, some Greek, some French, and some German in some cases. So the Chinese system provides you a tool to teach some properties of the elements without requiring further knowledge on more than one language, more than 2, because your native language still counts. And what I found very interesting while teaching is to make comparisons between our native language here, Spanish, and the language of chemistry. Because when we understand chemistry as a language, we can make analogies between words and sentences and text and phrases. And also it gives us the perspective of what we are asking of our students. Because when you're teaching chemistry for a long time, you tend to forget all the things that are involved in for starters, for beginners to learn chemistry. You have to have your mathematics at point. You have to know how to combine symbols to make sense, to represent a formula, and link that to a concept, maybe to relate it to the angles, the structure, the chemical properties, the physical properties. We ask kids to also understand graphics that are not part of their daily life. So at some point, it's a lot, and sometimes the curriculum is organized in a very heavy way. That's why I'm trying to find a way to introduce them to the symbolic language by playing games and trying to help them find patterns. If we help them to find patterns, we train them to find patterns, they can project that and use that to solve new problems. This is one of the things we are going to keep on working with the framework of different pedagogies, with different theories, one of them being Ausubel's meaningful learning. This is a very old chart, but it helps synthesize what our brain does when we first learn something, and how we move it to the long-term memory, and how can we access to that information that it's in the long-term memory. We need to create, first we need to compare the information to what we previously know and make categories and load that new information into some categories. Then the hooks that we create, in this case, what I'm proposing is to use the symbols, to use the Chinese characters as a hook to connect with the chemical symbol and also with some physical properties. Some of the symbols also have, like bromine, it also have another property, which is the smell. In the Chinese name, the other character means that it's smelly. So in some cases, we can also play with other qualities beside the physical state of the element. And then these hooks will help us to access that information when we are questioned, and to produce the answers that we want the kids to produce. So to end this presentation, I would like to sum up what I'm thinking when preparing this type of activities for my students. I want them to be able to identify common elements. In this case, they're radicals or roots, and organize information into categories. This is like a previous step, and then we can move on to help them analyze why the periodic table is organized in groups or periods, or what the elements have in common. It also helps, as I mentioned before, to provide some physical information, some information about the physical state of the elements. It helps creating a hook to call the information back when we need to access that information. It also acknowledged the thing that students are immersed in an anime and manga world nowadays. They are familiar with the symbols, more to Japanese kanji than to Chinese hanzi, but they are similar. And it also presents a challenge. You need to change your mindset, and also gives the idea that this is something that I will work on in a different line, but how a multilingual brain presents several cognitive advantages over a non-bilingual or no multilingual brain. This is something that it attracts me a lot. And of course, just for the fun of it, because I need to be playful when teaching, to enjoy myself as well as the kids. I will leave you with this artist quote: language, philosophy, and science are interwoven into the design of words, which are manipulated to create surprising illusions. I believe that when we dive in the world of linguistics in all their aspects, they lead us to an amazing world. Sometimes we reach the point of no return and we become completely crazy, but it's a path worth taking when analyzing things, and when we want to look things as a whole, not as separate parts of everything. We need to think of knowledge as an holistic thing and not isolated items that have no connection at all.
Thank you, Andrea.
Thank you at all.
Thank you, Andrea. That was very interesting. We don't have very much time for questions unless we go a little bit into the break, so I'll ask people to raise their hands if they have questions. But please keep them brief, because we should let people go to the break as well.
I cannot see how to share. I cannot unshare.
You can't unshare? You're stuck. Alfonso has a question. Alfonso.
Yes.
Very quick comment. Congratulations. Ni hao. The already complex network of chemistry. Thank you very much.
I wasn't able to listen. It was cracking all the time.
It was very unclear, your reception.
Yes.
Can you repeat it again?
Type it on the chat?
Or put it in the chat, yeah.
Yes.
Well, later on I'll contact you. That's all. I mean, thank you.
Okay.
Okay, Eric.
Hi, thank you very much for your talk. How about Japanese characters? Is it a similar story about how they developed?
Japanese characters use the kanji, and kanji are derived from the traditional Chinese.
Okay.
I haven't made the comparison yet between Chinese, Japanese, but I also want to do it between Chinese, Japanese, and Korean, because they share history, and ancient Japanese shared the Hansu, they call it kanji, and ancient Korean share Hancha, which are the same. Before before Mao's decision to change the characters, they were the same.
Okay. You should maybe collaborate with Yona, because she knows all about that.
I cannot hear you. It sounds like a very high pitch.
The microphone doesn't work.
Does it work now?
No, it's good.
Yes.
Okay, so the ancient characters you mentioned are also used in Japanese as is. The metal is different, but anyway. Surprisingly or interestingly, in these letters are also in the Bible. I mean, these ancient elements are also, their names is in the Bible, what you call the Old Testament. And then Japanese combined is a katakana or kanji or both. So again, this is a long discussion, but I put in the change my article about Roscoe and Japanese translation of some English chemistry and Hebrew. So please check this article online, and maybe we can discuss further later. Thank you.
Yes. Thank you very much.
So thank you very much. I think what we'll do now is we'll have the 10-minute, the break until, for 15 minutes, we have a break, or just a little bit more than that, 16, 17 minutes. And then we'll resume again with the final invited speaker.